In this tutorial, I'll go through the process of determining the orthogonal components of a vector. In this case, the vector is a force. Orthogonal means at 90 degrees, so we're going to determine the components of this force at 90 degrees to each other. And the first thing that we need to do is to describe those directions. So we use coordinate axes at 90 degrees to each other, and in this case we're going to use x and y coordinates at 90 degrees, x being horizontal to the right and y being vertical upwards, and we'll use these to determine the x and y components of the force. So firstly, we'll just define the angle at which the force acts relative to the x-axis. So we've drawn that on our diagram to be able to refer to that. Our two component vectors or forces directed along the x and y directions must add vectorially to give us the total force, or the original force, vector F. So we can start drawing in lines perpendicular to the x-axis or parallel to the y-axis, and so here we've drawn in, and also parallel to the x-axis or perpendicular to the y-axis, and then along the x-axis here we've got our x component, and we'll call that f subscript x, and in the y direction our y component f subscript y. And if we remember our vector addition, if we added fy tail to the tip of fx up here, that would close that triangle, adding up to give us the force F. Alternatively, if we added the force x up here, then Fy plus Fx gives us the vector F. Okay, so now we note that we have a right angle triangle here, and we can just make use of our properties of a right angle triangle, and we note that this side here is the adjacent of that to this angle here of our right angle triangle. So the length of this line here will be just the hypotenuse times cos of this angle. So f cos theta will give us our vector component in the x direction fx. And then we can do the same thing for the y direction. So fy here, that's this opposite side of the triangle. So that force Fy will be F sine theta. Alright, if we now just put some numbers to that to just get a feel for the values of the components. If we have the force F equal to 5 newtons and the angle theta equal to 35 degrees, then it's a simple matter of just substituting those values. So Fx, the component in the x direction, will be F cos 35 degrees equals 4.096 newtons, and similarly for the force component in the y direction, F sine 35 degrees equals 2.868 newtons. Note that the force is not always defined relative to the x-axis. Sometimes you might find that the force is defined relative to the y-axis or some other axis, and so therefore you need to interpret the angles and the trigonometry from the right angle triangle in order to correctly calculate the components. So in this case, if we look at the angle between the y-axis and the force F and call that the angle alpha, then Fx is now the opposite. Okay, so it will be F sine alpha, and Fy is now the adjacent, so that will be F cos alpha. And I'll leave it to you to do the calculations to check that you get the same values for Fx and Fy that we got previously. If you're going to do further calculations with these numbers that we've determined, then you can keep them at 4 or more significant figures. But if you're going to, if this is the final answers, then you should round up appropriately. So usually to 3 significant figures. So this would be 4.10 and 2.87.